Hello, and welcome back to the second session of our extrusion module. Today, we are moving into the details of a very important equipment in our process, the conditioner. Now, you might recall from our previous discussion that the conditioner plays a crucial role in starting the cooking process for our product and preparing our mash of product for further processing at the extruder. But today, we're going deep into the very details of how this all happens. Before moving into the details of the conditioning process, let's take a moment to understand why this equipment is so crucial. Essentially, we have two primary reasons that drives the importance of this step. Firstly, by initiating the cooking of the mash of product within the conditioner, we set the stage for higher quality product. How does this magic happen? Simple. When our mash of product is properly cooked in the conditioner, the pellet structure becomes stronger, resulting in fewer fines, and ultimately producing more durable and robust pellets. Secondly, the material entering the extruder, post-conditioning, is prepared for optimal processing. That material falling from the conditioner into the extruder is hot, it's cooked, and this translates to reduced motor load. With less strain on the extruder motor, we can ramp up our extruder's capacity, achieving higher throughput rates. So, you see, good conditioning isn't just about quality, it's also about increasing the extrusion line capacity. But there's more. Effective conditioning also plays an important role in minimizing wear on our extruder parts. When our material flows smoothly through the extruder, the screw and barrel have less friction, resulting in less wear on extruder parts. So, in essence, the conditioning process isn't just a step in the production line. It's the equipment that can improve our product quality, line efficiency, and increase the longevity in extruder parts. Now that we've covered the benefits of the conditioning process, let's start talking about how this equipment works. The conditioner does three things at the same time. Firstly, paddles agitate the mash of product, conveying that mash towards the extruder. But why using paddles, you might ask? Because paddles can convey, at the same time that they agitate the mash of product inside the conditioner. And this agitation is very important to mix the mash with liquids that will be injected inside the conditioner. And like we just mentioned, we will inject liquids inside the conditioner. Here we can inject water, steam, oil, and slurry into the mix. But let's focus on water and steam because they are the most important ones. The water serves to humidify the mash, while the steam initiates the cooking process. So, in essence, while the mash is twirling and swirling inside the conditioner, because of the paddles, the water and steam work their magic, transforming the dry ground mash of product into the hot, cooked mash ready for extrusion. And here you have a very important image about what we want to achieve inside conditioner. This image here shows what occurs when starches undergo gelatinization. We can find starches in many raw materials that we use to produce feed. Just to mention few of those raw materials, we have wheat, corn, cassava, or rice. These raw materials are known to be high on starch content, but this is what happens to starches when they get cooked. But, to use the correct terms, here we are going to use the word gelatinized. When starches are cooked or gelatinized, they become something very similar to a glue. And this glue of starch is used to bind the mix of ingredients that we have inside your pellet. The starch is the component that will create the structure that will hold your pellet together. Well, in every single recipe that we always have some amount of starch. And this amount will vary depending on the product that you're producing, depending on the characteristics of your product, depending on the cost of your recipe. But the important thing here is that you always have some starch in the recipe. You are processing, and the conditioner is where your starches, whether it's coming from wheat, rice, corn, or any other ingredient source, is gelatinized and turned into that important glue. We can say that gelatinizing starch is in your conditioner. It's like the first step towards producing a strong and robust product. In these three pictures here, you can see what happens with starches when they are heated up. This sample of starch was heat up at 80 degrees. At first, the sample melted down. And after some time, that starch started gelatinizing, and it became this transparent liquid, very similar to a glue. And this is what we want to achieve in our conditioning process. We want to transform the starch that we have in our recipe and make that starch to become a glue, because is that glue that will give the structure to our product? Is that glue that will make our pellet strong? Important to mention here, that starch can come from different sources like wheat, corn, rice, just to mention few of the available sources. Most of the starches start to gelatinize in between 55 to 60 degrees, but depending on your source of starch, the gelatinization process start to happen only at 85 degrees. But like we said, it is not only about temperature, starches also need time to gelatinize. But then, how much time does the mash need to stay inside the conditioner to gelatinize our starch? Simple and straight answer, at least 2 minutes. We need our mash to stay inside the conditioner for at least 2 minutes, 120 seconds, and no less than that. That is the amount of time that we need to humidify the mash, to heat up the mash from ambient temperature up to more than 90, 95 degrees. To mix the mash with water and steam that we are injecting, again, we need the mash to stay inside the conditioner for at least 2 minutes. In fact, we can calculate and determine how much time our mash is taking to move along the conditioner from inlet to outlet. But to be more practical, we can open the conditioner door and see how full of mash is our equipment. The procedure is very simple. All to have to do is, while in normal production, hit the stop button for the conditioner motor and screw feeder. With that, the mash that is inside the conditioner will stop moving forward, and the feeder will stop sending more material into the conditioner. After that, you just need to open the conditioner doors and look inside of it. The rule is to have mash at the shaft level, just like in this picture. If the conditioner is too full, we will start having problems to properly mix the mash with water and steam. If the conditioner is too empty, we will have such a thin layer of mash that steam will pass through the mash and escape from the conditioner chimney. If the conditioner is too empty, it also means that we are losing the opportunity to increase the time that the mash is spending inside the conditioner and cook this mash better. Let's recap again what is happening inside the conditioner. Mesh is entering the conditioner from the feeder. And the very first thing that is going to happen to the mash of product is that petals will start moving the mesh around, and you will start injecting water on top of the mash. Okay, we know what to do. We know that we need to inject water, but now I'm going to talk more about how to inject the water. Injecting water correctly is one of the things that will guarantee that you have high-quality product at the far end of your process. The thing is that we don't want to pump water inside the conditioner. We want to spray the water evenly on top of the mash. And to do that, the water needs to be at high pressure in our water pipeline. And we also need nozzle sprays. The nozzle sprays will guarantee that the water is pulverized in very small drops of water. Remember, the idea is that your whole mash of product that is inside the conditioner receives the same amount of water. Your whole mash should have the same moisture content. We don't want part of the mash to be very dry and part of the mash to be very moist. We want the mash water content to be very even, and your nozzle sprays need to guarantee that. We need to have nozzle sprays and pump the water at high pressure to pulverize the water on top of the mash. But then we can formulate a very important question, and that is, how can we know if we are injecting water correctly? I mean, what is the best practice there? Okay, the very first thing is, if your water injection is stable, and to know that you need a water flow meter. A water flow meter is an instrument that will tell you how much water is passing through your pipeline. Consequently, it will tell you how much water you are injecting. By knowing how much water you are injecting, you can record that number down and start building your extruder running parameters guideline. But more than just knowing how much water you usually use for your future reference, it is important to know if your injection is stable. If you have a manual flow meter, operators can record numbers from every half an hour, or they will look at the flow meter from every now and then. But if your flow meter is digital, then you can do a lot. With a digital flow meter, you can get that data input as a graph. Then you can really see if you're having fluctuations in your water addition, And if you have fluctuations, you can check your pump and then you can start investigating. The important thing is that you need that data to know if you need to improve, if you need to work with your water injection line. And then the last thing that I want to talk about injecting water is about the temperature of the water. Remember why we are injecting the water. Again, we are injecting the water because we want to humidify our product to be able to cook it, to gelatinize the starches. That's the objective. So if we are injecting water at, let's say, at ambient temperature water, meaning that your water is at 15 or maybe 20 degrees, what will happen is that when you are injecting steam at your mash inside the conditioner, you need to heat up this moist mash that is about 15 to 20 degrees, from those temperatures up to 85, 90, 95 degrees. So the gap in temperature that you need to increase is very, very large. Keep in mind that starches, depending on their sources, start to gelatinize at high temperature. Most starches start to gelatinize between 55 to 60 degrees, but some only at 85 degrees. So if you inject water at ambient temperature inside your conditioner for a period of time, all you will do with your mash of product is to heat it up. Your starches won't be gelatinized. For this period of time, when you are still increasing the temperature of your mash. Now, if you are injecting water at, let's say, 55 or 60 degrees, from the very beginning of your conditioner, the dry mesh is already receiving hot water. And because the water is hotter, from the very beginning of your conditioner, your starches will start to be gelatinized. And this trick will give you the exact same effect of prolonging your retention time or having a larger conditioner. Using hot water is very important because that gives such a good result. It improves your product quality. It reduces your steam consumption. Using hot water has so many benefits. If you can try to use hot water in your conditioner, you won't regret about that. All right, we know that we need to inject hot water, but the other thing that we can see in this image is where the water nozzles are located. You can see that they are located very close to the inlet of the conditioner. And of course, there is a very good reason to have the water injection spot close to the inlet. Keep in mind, we always want to inject water before you inject steam. And you do that because the objective of injecting water is to humidify the particles. We want to humidify the starches that will be cooked and will be gelatinized. Just to clarify, one good source of starch is rice. Rice is a common ingredient in our factories, and rice has a very high starch content. If you want to cook rice at home, the very first thing that you do is add water on top of it. You add water on your rice cooking pan, and only then you turn your stove on. You never do the opposite, because if your cooking pan doesn't have water, you will burn the rice you are trying to cook. And here's the same thing. You need to add water first to heat up and to cook your mash of product later. Now, let's understand why water injection nozzles is located on top of the conditioner. Water should always be injected from the top of the conditioner. And the reason for that is very, very simple. The reason is that gravity will push water downwards. Okay, think about what is happening inside the conditioner. The conditioner paddles will push the dry mash upward, tossing, throwing, and agitating the mash of product up in the air. By injecting the water at the top of the conditioner, gravity will make its job and will push the water down. And the water that is traveling downwards will encounter the dry mash that is traveling up. If we add water on top of the conditioner, we are in fact using gravity to help us. Steam is the next thing that we want to inject inside the conditioner. The steam nozzles should always be placed along the conditioner after the water nozzles. And here is the opposite of water. The water comes from the top. But in the other hand, steam needs to be injected from the bottom of the conditioner. And the reason is, again, very simple. Steam travels upward. We want to add steam from the bottom, so steam can also be mixed with the mash. If we do the opposite and inject steam from the top of the conditioner, a lot of this steam would not mix with the mash and would just escape by the conditioner chimney. and that would be inefficient and expensive because we would be wasting steam. By injecting the steam from the bottom of the conditioner, the mash will act as a barrier for the steam to escape. And as is acting as a barrier, the steam is heating the mash up and cooking our mash of product. Steam should always come from the bottom of the conditioner, but injecting steam inside the conditioner is not only about where to put it, it is not just about having the steam inlet points underneath the conditioner. We also need to take in consideration the steam pressure that we are using and how we are controlling the steam injection. So let's just talk about the pressure. In your operation, you have your boiler. The boiler will generate the steam that we are going to use in our process, and then from the boiler, the steam is transferred inside the steam pipeline up to your extrusion lines. But the thing is that the steam that comes from the boiler is at very high pressure. The steam pressure that comes from the boiler is much higher than we need to produce our product. It is much higher that we need to inject inside the conditioner. Just as a reference, your boiler usually generates somewhere around 8 to 10 bars. If you are using the steam at that high pressure inside the conditioner, the pressure will be so high that the steam will blow away all the material that you have inside the conditioner. And most of that steam would just escape from your conditioner chimney. What we want to have is inside the conditioner is something different. We want to use steam at very low pressure, somewhere between 1.5 to 2 bars. But the lower this pressure, the better. We want steam at low pressure because that low pressure will make the steam to travel together with the mash of product, heating up and gelatinizing that mash. That will also ensure that we don't have any steam escaping from your chimney. If steam is escaping from your chimney at your conditioner, it means that you're losing money and losing steam. Remember that it is very expensive to generate steam, so you need to be very wise when using this resource. And another important thing to mention about the conditioning process and steam injection is about the temperature of the mash that is leaving the conditioner. Here I want to talk about the temperature that we want and how to measure the temperature of the mash that is leaving the conditioner and falling into the extruder. For your reference, most of the time, you will be working with the mash temperature between 90 to 99 degrees. That is the temperature of the mash that is leaving the conditioner. The amount of steam injected inside the conditioner will determine how hot the mash will leave the conditioner. If you want your mash hotter, you just need to inject more steam. If you need your mash cooler, you just need to inject less steam. But again, in most cases, your mash should be leaving the conditioner somewhere between 90 to 99 degrees. This temperature is not only important to gelatinize starches and increase pellet expansion at the extruder, but exposing the mash at hot temperatures for a long period of time inside the conditioner will guarantee that we kill any bacteria that comes in our raw materials, and this is very important. Pressure is understood. We know that for the conditioner, we are going to reduce the pressure from the boiler down to 2 bars or somewhere about that number. And the other good thing about reducing the pressure from the boiler is that this pressure is going to be way more stable. The pressure in the boiler can fluctuate up and down, but this fluctuation should not happen after reducing the steam pressure. If steam pressure is constant, then the next step to have our mash of product leaving the conditioner at the correct temperature is to measure the temperature of the mash correctly. It can sound a bit strange or a bit obvious, but we need to guarantee that we don't have a misled reading of the temperature of our mash leaving the conditioner. We need to really have the certainty that we are measuring that temperature correctly. Remember that the temperature is going to be used as the source of information to adjust your steam injection. This means that if your temperature is lower than you want and you need to increase the temperature, all you have to do is add more steam. On the other way around, if your temperature is too high, you need to reduce the amount of steam that you are injecting in your conditioner. So, that temperature is very important, and therefore, it is very important to measure that temperature correctly. Most factories will use a thermometer here. This is an industrial thermometer called PT100. But as important as the type of sensor that you are using is the location that the sensor is placed. In many factories, we have seen that the sensor is not in the correct place. This means that factories are getting a misled reading of temperature of the mash that is leaving the conditioner. The correct place for this sensor is always at the far end of the conditioner and always in a place where we have constant flow of material. The mash of product that is leaving the conditioner should always be touching that sensor. The mash of product that is leaving the conditioner should pass through the sensor and hit the sensor, and then the sensor will give the reading of the temperature. In many cases, we see factories that have the sensor placed in funny places, or places where we don't have constant flow of material on top of the sensor. So instead of getting the temperature of the mash of product, sometimes, because the sensor is placed in the wrong position, we have steam touching the sensor. When that happens, you will see weird temperature readings, like more than 100 degrees. If you have that type of temperature reading in the conditioner temperature sensor, you should know that the sensor is placed in the wrong place. But to correct that is very simple. All we need to do is to guarantee that we have flow of material passing through that temperature sensor. Simple as that. Up to now, we have covered a lot about the conditioning process, but focusing on steam injection, we have learned that we need to reduce the steam pressure that comes from the boiler down to somewhere between 1.5 to 2 bars of pressure, because that will give us a slow and steady flow of steam. We have also learned how to measure the temperature of the mash of product that is leaving the conditioner and going into the extruder. This one is also simple. All we need to do is to use an industrial thermometer and place this instrument at the very end of the conditioner, in a spot where you will have constant flow of material hitting the sensor. Now let's talk about how to control the amount of steam that we inject inside the conditioner. Let's start thinking about the manual process, and then we will move to how the automation can help us here. Well, in the steam pipeline, just before the conditioner's steam inlet spot, we will have a set of valves. We will call them control valves. The arrangement should look just like in this picture. Each of those valves will control the flow of steam that we have at one steam hose. The thing is that the more the operator opens these valves, the more steam we will inject inside the conditioner. And if we inject more steam, the temperature of your mash of product will increase. Your mash will get hotter. Now, if you start closing the steam control valves, the opposite will happen. If you start closing the valves, you will reduce the flow of steam that you are injecting, and consequently, the temperature of your mash of product will fall. Now, looking at the operation, if you do have this manual arrangement to control your steam injection, what will happen is that the operator will open and close this set of control valves to adjust the amount of steam that he is injecting. Just to give an example, just to clarify a bit things here, imagine that the operator wants the mash leaving the conditioner at 95 degrees. He wants that temperature to have the mash well cooked, well gelatinized. He will open the steam valve a bit, and then he will observe the reading of temperature that he is getting. So let's say that he gets a reading of 80 degrees. That is the temperature of the mash that is leaving the conditioner. Okay, what he will have to do now is to open up the steam valve a bit more. He will wait until the temperature gets stable, and now he gets a reading of 92 degrees. This is still not what he wants. So he will open the valve a bit more. But now, instead of reaching 95 degrees, the temperature goes up to 98 degrees. What he will have to do now is to close that valve a bit to get the 95 degrees that he wanted in the first place. You see, this will be a continuous job of observing the temperature of the conditioner and regulating the opening of the steam control valves. This adjustment of the opening of the valve is something that the extruder operator will have to do all the time. Now, we can make an upgrade in our system and automate how we inject the steam in our conditioner. This automation is easy and cheap to do, and then things will change. Things will get much easier. To automate this system, all we need to do is to substitute this manual control valves by a special valve called proportional valve. This valve will do the exact same thing. It will open to inject more steam and will close to inject less steam. The difference is that this valve is automatically operated. We just need to tell this valve how much we want this valve to open. And then we can link the temperature of the mash leaving the conditioner with the opening of the steam proportional valve. Let's see this example to clarify the things up. Here, the operator is asking the system to have the mash leaving the conditioner at 95 degrees. All the operator needs to do is to ask for a given temperature. And the proportional valve is going to open or close to adjust the amount of steam that we are injecting, and consequently reach the temperature that the operator is asking for. If the temperature is too low, the valve will open more. If the temperature is too high, the valve will close. The valve will work without the intervention of the operator to reach the temperature that the operator wants and to maintain the temperature constant. The valve will do all that work by itself. All the operator needs to do is to ask for what temperature he wants. Again, here you see that the operator have asked for 95 degrees and the valve is opened at 82%, and the temperature of the mash is now 95.4 degrees, which is pretty much what the operator wants. So linking the temperature of the conditioner with the opening of steam proportional valve, it is the easiest way to control the temperature of the conditioner. This is a very simple automation, and that ensures that you have a very constant temperature of your mash of product leaving the conditioner, and consequently, it contributes for you to have a very stable extrusion process. Well, we are heading to the end of this presentation. So, just to recap things up, remember that the conditioner is used to start cooking the mash that is coming from the grinding and mixing process. This dry mash coming from the grinding and mixing step will enter the conditioner where it will be mixed with water and steam by rotating paddles. These paddles are very important as they will not only mix the mash with water and steam, but will also make this mash travels inside the conditioner towards the extruder. And last but definitely not least, we have covered how water and steam are injected inside the conditioner. Water should come from the top, steam from the bottom. The conditioning process is very important. It relates directly to product quality. Therefore, the better the performance of the conditioner, the better the will be your product quality. Now, I want to invite you to continue watching the extrusion classes that we have in this module. Just to mention a few of the things that we will explore. We will explore the concepts behind the extruder screw and barrel design. We will learn the art of tweaking those extruder parameters to produce high-quality feed at high capacity. And don't even get me started on troubleshooting production problems, because we do have a lot about that. So my friends, consider this your invitation to join us on this journey. And whether you're thirsty for more insights, have questions, or just want to discuss the challenges you're facing in your factory, we're here for you. All you have to do is to shoot us an email at ebf.training@outlook.com and let's start a conversation that'll light up your production line. Now, I thank you for your audience. See you in the next class. Bye.